everybody, this is Tiago from Coderversity, and in today's video I'm going to be teaching you how to develop a simple grocery basket simulator with .NET 8. In today's video you'll learn how to set up a basic console app, make an SQL Server database connection using .NET 8 and Entity Framework Core 8, as well as how to use a few of the latest .NET 8 updates. So what are you waiting for? Let's dive in. The problem we have to solve is quite simple. We have a couple of items with a price, and depending on the input we give, we receive a receipt with the total that we have to pay. I'm developing in VS Code, but feel free to choose an IDE of your preference. Let's start by creating a console app and call it Grocery Basket Simulator CV for Codeversity. Now that we have the project created, let's define the layers of the application that we are going to use. Let's put it under this folder. I opted to build the app with onion architecture because of the domain-driven design, since the problem is so domain-centric. Firstly, I'll create a presentation layer with 2 zeros to be the first folder presented. Next, I'll create the services layers with a 01. After that, the repositories, then the domain, and lastly the cross-cutting layer that will be the transversal to all application. Cross-cutting. Now that we have the onion, starting bottom up, we have the domain that contacts with the repository layer, then the services that will make use of the repository, and the presentation for last. Let's define the domain. We need a basket, obviously. So let's type in baskets.cs. Let's define the class, and here take a closer look on how I'm defining the constructor at the class level. This doesn't happen before .NET 8. This is called a primary constructor. From here, we will create a dictionary that represents the items in the basket and the respective quantity. So the key will be the name of the item, and the value will be the quantity present in the basket. Because of the primary constructor, we can initialize directly with the keyword init and declaring a new dictionary. Next, we need the item class that will be part of the basket. So let's add it. Item.cs, and then it will be initialized with a name and a price. Let's use again the primary constructor. We will also need an ID because we will persist the items in the database. In fact, that's all we are going to persist in this app. As you can see, we also use the primary constructor here. Now that we have the domain defined, let's add a functionality to the baskets after I finish writing here the item. The init, And let's add the name, let's initialize actually the name and then the price the same way. Here, as you can see, I use for the primary constructor like before, and we'll do the same for the price. We will use the parameters we receive in the class. So now, let's go to the baskets. Let's enable the item addition. And here, as you can notice, the item names, since they are received by user input, they will be our dictionary keys for the item collection. We will check if we can add the item, and if we can't, it means we already added it, so we will just increment the quantity by 1. So the dictionary has this triad method that returns a boolean if the adding was successful or not. Let's add the name validations for later. So, like I said before, if we can't add the item, it means the item is already present. So let's just increment the quantity. Now let's go to cross-cutting and add a static class for the item helpers, where we will have a method to normalize the item name in order to interpret lower and uppercase names. Let's do like we did previously. This is a static class, as we don't need an instance of this helper to use it. Normalize the item name. And then let's trim it and put it in lowercase with an invariant culture. I will now replace the parameter name with the return of the helper here. Let's just create a variable to reuse this normalized item name, and in order to be more readable. The next step, we need to connect the items with the DB entity with the EF Core 8. So we will add the necessary packages for this matter. The Entity Framework Core 1, that is using .NET add package, and then Microsoft dot extensions, Entity Framework Core, sorry. Now let's run it. Oops, I'm in the wrong folder, so let's dive in the next folder. And then let's run it again. It should work now. And then we add the SQL Server one for a connection to the database. Let's just replace the last name with SQL Server. All set up now. Next step will be obviously the repository setup. In order to achieve that, to work with the Entity Framework 8, we need a nepdb context. So let's create it, starting with the usings from the packages we just installed. The DB context always has at least one DB set of entities. So after we do the setup, let's declare it. In our case, it will be a DB set of items. Next, we will initialize it. Let's write the constructor here. We are not using primary constructor since we are going to send this parameter to the base class. Now let's initialize it here. And now we need the onModel creating method. That is an override for the base class. So we define here the entity and the key. In our case, the entity is the item that has the primary key ID. Let's fix this typo. And now we have the onModel creating ready. The item here. And it's ready. Let's proceed with the repository interface. The interface is a contract that we must respect. So, meaning we have to implement what we have in there mandatorily. And we can use this for dependency injection. So this repo will mandatorily have to implement the getItem method that will return a nullable in case it doesn't find the item in our database, that we will call store, maybe, just for simplicity. As well as a save item to save the item in the database. So we need an item and then the price. Now after the interfaces, we need the concrete class that will implement the interface, the item repository itself. Let's declare it here. We will use again the primary constructor. This is a really cool sugar syntax feature from .NET 8, and it's more readable. So we will naturally use the DB context to get and save item. So let's declare it. Both of the methods have to use the context. So let's implement it. Firstly, the getItem. We will start by normalizing the item name using the helpers and retrieve it from the context. So let's declare a variable that will hold our normalized item name. There we go. And then we will retrieve it from the context with the improved .NET 8 linQ by using a first or default that returns null in case the item doesn't exist. So in this case, the linQ is transformed to SQL language under the hood. We will compare the names. We will search by the name, in this case the normalized item name, and the item name present in the database. Then we just return it. Now let's proceed to the save item. This will return a boolean to let the method caller know if it was a success or not to save. And to save, what do we need? We need a name, and a price. For the name, let's normalize it again and check if it exists by using the method any of linQ. So firstly, let's normalize it again, just for consistency. And then we will check if the item exists using the any without retrieving it to avoid unnecessary memory and processing. Let's compare by the name again, since the input will be names by the user. If it doesn't exist, then it means it's not present in the database. So we save it. So we will add the item to the context. Like we are writing here. And then we save the changes which will commit the changes in the database. Then we return true. The save was a success. Otherwise, it returns false. Now we have a DB context access, getting and saving items. We are using the get item here, and then we have the save item. So now for the database configuration, I've already set up in my Mac the image of an SQL server from Docker and ran it as a container. Let me know in the comments if you would like to make a video about it. Then I created a table for the items in Azure Studio in my local Mac. I have set the ID as a primary key and integer, the name as an n varchar not null, and the price also not null with 2 decimal places. As you can see, I have manually introduced the items since they are so few. Now that we have the DB setup done, let's get back to the project and add the package for configuring our app settings, which will contain our connection string as well as the dependency injection and the hosting, because we are developing a console app, so we don't need a web host. Let's add the package like we did before through the terminal. Let's use .NET add package Microsoft extensions configuration, and then we will just use the configuration JSON for the app settings. Now the dependency injection package, and then the Microsoft extensions for hosting. Now that we have all set, let's edit the program and make use of the packages we just installed, starting with the builder for the host, we will implement the app configuration. Let's use the packages we just installed. Let's refresh this typo here. And now, starting with the builder for the hosts, we will implement the app configuration. Here we have the host for the console app, and then we'll just configure it. We have a context of the app here and a configuration. So in the app context, we want to include the app settings file that we will in a bit create as false to optional and reload on change as true, meaning that the program needs mandatorily the app settings.json file to run, because it will contain our connection string to the SQL Database Server. And the next step, we will configure our services, where we will register our dependency injection and connection to SQL Server. So we configure the services here on the builder. And then we will just take the services to use the connection string, the context, sorry. So let's go with the default connection key for the connection string and then proceed to the dependency injection. Let me know if you would like to know more about the services lifecycle, since we are going to use transient here. But first, let's add the DB context, which we already have seen. Setting the options to use the SQL Server, which will make use of our connection string that we got before. And then we will register the services that we created. Let's add the transient lifecycle here for the item repo. Then the concrete class. And there, it's almost ready now. And let's build it. Now, let's create the app settings and put the default connection to the DB there. App settings.json, because by default the .NET will look for the connection under connection strings key in the app settings. Let's write here connection strings and then nest it the default connection string under the connection strings. I'm going to write down the connection string, but you guys will use the one that corresponds to your database and credentials, of course. So mine is localhost. My database name is master by default. My username is SA. And then I will omit the password here, since I use the personal one for testing. I'll just write password equals, and then I'll add it later. Let's make the encryption true and the trust item certificates, server certificates, I mean. As you can see, the password is empty, but I will later amend it when we will use it. Done. Now let's write the services which will communicate with the repo. Let's create the class. In this case, the iBasket service. That will be an interface which will later be used in the dependency injection. So we want to add items to the basket, so we will need to receive the name of the item, since that is our console input, and then the basket itself. Lastly, we will need for our output and for that we use the basket price calculation. So we'll create the method calculate total basket price, which will receive a basket. Now to the implementation of the interfaces. In this case, our iBasket service. Primary constructor again. And then we will have the item repository as private, since we are only going to access it inside the basket services. So let's make it private, item repository, the interface for dependency injection, and initialize it. The I will take care of the rest. Now let's create the methods and then logic to them. So in order to add an item, we have to make sure that we have it in store, quotes. That is our database. So let's make that condition. Let's firstly try to get the item. And if it exists, then we add to the basket and jump out of the method. So if it's not null, we get the item. Otherwise, let's throw a custom exception called item does not exist exception in order for us to catch this specific exception and ask again to input the items without exiting the program with error. Let's call it item does not exist exception and send in a custom message with string interpolation in order to output the item name. Let's create the exception under the cross-cutting layer. The cross-cutting layer is transversal to all projects, so it can communicate with any layer of the project. Voila! Class created. Let's do the same again. Send the message to the base class. And done. Now we are just missing the calculation of the basket. In this case, the prices of the items included in the baskets. So let's do it. Let's create here a method that is public. According to the interface, it returns a string and it's called calculate total basket price, where we receive a basket and then we will just go through it and multiply the price for each different item times the number of the same item it has in the basket. So let's declare the total as 0. And then go through the items like I said. And make the calculation. We go to the item repository to get the item. And for extra safety, let's add again the same exception in case we don't find the item in our store. This shouldn't happen, but either way, just for safety, in case we changed the other logic. And since each class has a single responsibility, I think this is a good practice. Let's add a custom message here where the item is not found. The key, which has the name of the item in the dictionary, and remember, the value in the dictionary corresponds to the quantity present in the basket of the item. And then we will just sum the price to the total using the basket item value. And we access it by item.price times basket item dot value. Then let's make an output here. Let's say total basket price is, and then we get the total by hashtags which determine how many places we want to display in the string. In this case, we want to display 2 decimal places here. And then the euro. As you can see, we are using the item repo in the service, which complies with the Onion architecture. Now, since we have a new service, we need to register it in the dependency injection in program. Now the services are registered and we have our program set to be ran. Done. Exciting. But for that, let's create a presentation console to interact with the user. Now we have it ready. Let's minimize this and create the menu. The menu will be declared as a public class and we'll use the basket service. This class will just take care of the user interaction with the app, so let's display a menu while the user doesn't type to exit. Let's first declare here and initialize the basket service for dependency injection, like we already know, and using the primary constructor. Now, let's display the menu. Let's say while true, which means that we have to have a condition inside to break this loop. That will be the user typing E to exit. So Like I said before, we created custom exceptions in order to catch specific errors in the code and not blow the program. So we surround the logic with a try-catch clause. Let's put a beginning input introduction. Let's go put here the input beginning using the constants. The constants file, we will create it and put it under cross-cutting, since we will reuse it, the expected input beginning, in several places. And then type P to exit. Adding the constants here in a new file. Let's call it constants.cs and make it static because, again, we don't need instances of constants. And then let's create the input beginning. The expected input beginning will be price baskets. So let's write it. And we'll just add here a catch so that we can fill later. Now let's read the user input and display the menu here. Let's read the line that the user inputs, because we don't want just the first word. And if the user enters E, the program will exit, like we explained in the input. Otherwise, we will create a basket and try to insert the products that the user typed. And then, to get the items with the input and make a readable logic method, let's create a private getProductList method. This will trim the input by deleting the white spaces in the end and beginning. So let's make it private, since we are going to only use it here in the menu. And not on this bracket, in this one. Let's make it static. And we will receive a list of products. And then let's proceed to the trimming. Let's declare a variable that will hold the trimmed input. So let's put input.trim for the start and the end. And after trimming, if either we don't have any words or input at all, which means if the input length is default or 0, or the input is null, we will just throw another custom exception called input exception. And this will make the user retry the input when caught in the try-catch clause. Let's use the constant again here and create the exception in the respective folder that we added, just like the previous one. Let's replace this with the constants and use string interpolation. Let's add the exception now. This is our simple exception handle system. Same process again. Let's send a message to the base class that is the exception, and done. Now let's get back to the menu. Now, if everything is okay with the input, then let's get the item names by splitting the string with a white space. Now, we declare a variable for the input beginning, and we just use the split input 0 to validate if the input beginning is the correct one. If it's not, constants dot expected input beginning. If it's not equal, then we will just throw again the input exception. Let's put here the string invariant culture ignore case, not to be so picky with the user input. If this matches, let's throw again the input exception. Let's copy the same thing. With this, we just need to create the product list by skipping the input beginning, that is price basket, because that's not a product. And then we just return the list. Here, we enumerate the list, and then we will return it. Done. We have our method, product list. Now that we have the product list, let's add the products to the baskets using the logic from the basket service that we implemented before. Let's go one by one, because we do not support a list to add to the basket, but feel free to implement it. We just use the service method and fill the parameters that it needs. And lastly, we will calculate the total basket price and output the result to the user. So let's get the checkout message by using the calculate total basket price in the basket service. Let's write a minimal receipt. Let's put a bit fancy here with hashtags saying your receipt, and then we will output the total that we got from the calculate total basket price on the checkout message, and then the end of our receipt. Now we will catch all the possible custom exceptions and output their messages to the user. So we have the item does not exist exception, and we will print a message, console.writeLine ex.message, and then we just copy paste and replace with input exception the same thing, and here actually I believe these are the only two exceptions that we created. Our program should now be ready to be displayed and run. Let's call the menu in the program and see, since on the program level we have to get the basket service registered service, because we can't use dependency injection here like we use in the repo, for example. So let's do it. Oops. Var menu equals a new menu, and since we need the basket service, we have to go to the host services and get the required service. And then we specify for which interface we want the type. Now, let's call the menu and display it. Nice, let's give it a try. Let's build a project first. We have it ready. Succeeded without any warnings or errors. Let's run it now. Okay, so let's try the preset basket, that is the input beginning and apples. And there we go. We have the total basket price is €1. Let's confirm it in the database. Apples, €1. So it's correct. Let's try another input. Let's try a lowercase 1. And then apples again. And it worked again. Awesome. Now let's try an invalid one. Invalid start of input expecting price basket. This is why we created our custom exceptions. Now let's do again. The item random does not exist in store. Again, the custom exceptions and try catch are working. Let's try with multiple items. With apples, bread, and milk. The total price is 3.1. Let's confirm it to the database. Apples 1 plus 80 cents plus 130. So the result is correct. There we go. We have your own app. Awesome. And that wraps up our tutorial on Grocery Basket Simulator. I hope you found this project helpful and you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.